Thank you. I'm pleased to be participating in the webinar today. My name is Dave Watchell. I'm the director of our water sector at Esri. I'll talk about, if you don't know who we are, I'll talk a little bit about that. And today I'm going to talk about GIS standardization in the stormwater industry, and really from my perspective, how it relates to the interest and the role of technology providers. So just can you verify that you are seeing my screen here?
Yep, we got it. Looks great.
All right, good. So if you don't know about Esri, we are a GIS company. We build a software called ArcGIS, and we really believe that GIS can make a difference in every organization. That really is our DNA. But one of the points I want to make here is not necessarily about who we are, but who we are not. We're not stormwater engineers, we're not stormwater program managers, and we're not regulators. And we don't really have a stake in the stormwater industry other than wanting to provide the best-in-class GIS technology that we can to help the industry solve its problems. And by doing that, that's what will make us successful in our commercial venture. So today, I'm going to talk about data in the context of a GIS framework. Esri's participation in providing GIS data and schemas and models in the stormwater industry up to this point, and then how we can serve the industry moving forward. So to get started, I have a few definitions that I want to go through to set some context. So the first one is a data standard, and here we'll just use the EPA definition. So data standards are documented agreements on representations, format, definition, structuring, tagging, transmission, manipulation, use, and management of data. So therefore, standards establish items like the name or the description or the notes or the XML tags of data. A schema is then really the blueprint or the architecture for how that data will live inside a database or inside a software system. It defines the tables, the fields in each table, the relationships between the fields and the tables, and the grouping of objects within that database, or now in web technology, in a web service. And so on the screen here, we just have an example of our older water wastewater data schema from 2005. So the last definition that we'll look at is the standard data model definition. So the standard applied to an industry. A standard data model or industry standard data model is a data model that's widely applied in some industry and can be shared amongst competitors to some degree. They are often defined by standards bodies, can be defined by database vendors or operating system vendors. So if you think of the role of Microsoft in the relational database, going back a couple of decades. So here on the screen, we have an example from the water sector of a industry standard, and that's from NASCO. So NASCO sets industry standards for the assessment, the maintenance, and the rehabilitation of underground infrastructure. They do this to improve and standardize how data is collected and how it's used to repair or replace infrastructure. Now, in the case of NASCO, they go so far as to certify vendors on their data standard. So as a vendor, there are decisions to be made whether or not to certify the software on the data standard. Now, in the case of NASCO, Esri adopted the PACP standard in our sewer solution for pipeline assessment, but we didn't certify our software on it. However, we do have partners, particularly in the CCTV space, that do certify their software on the NASCO standard. So it really gets into, various factors such as, how the standard would impact, what a software company could do to, evolve and extend their software. It might pertain to, if you don't certify, you might have competition that puts you as a disadvantage. So there are different factors to consider there. So over time, the evolution of technology drives changes in data and data schemas. And in the last 20 plus years that I've been in the water and the GIS industry, I've seen 3 major shifts in technology that actually drove changes in our industry models. So what happens is that their new technology comes along. This drives new data formats, which creates new blueprints for data structures, which are really the logical representation of that data. Those new blueprints turn into new conceptual representations of that data, which get incorporated into software solutions. Then users use the data, their requirements drive adaptation of those conceptual models, and then new technology comes along again and advances, and there's something new to have to deal with from a technology provider or from someone who uses that technology. So if you've known Esri long enough, you can remember back to the days of coverages and shapefiles prior to the year 2000, and that was a very flat data structure. In 2000, Esri began incorporating relational databases into our software. And at that time, Esri worked with many of our closest customers and partners to develop a common data model for that new schema for the industry. Then stormwater was included in a sewer storm combined model. That model was widely adopted by customers around the world, and our partners built their technologies on top of it. And it served as, what I'd say, quote unquote, would be the standard GIS data model for water and wastewater for about a decade. And when I use the term standard here, this is not based on a formality of, maybe association or somebody certifying or saying that was the standard. It just rather came to be because of the widespread adoption of that model. Then in 2009, Esri began providing what we referred to as industry templates that grew into formal solutions. And when the solutions team started to expand across multiple industries, they quickly realized that they needed a common model to deploy from, so they created a new model. And this is what we referred to as the local government information model. This model then quickly became the new standard for GIS users because we built all of our solutions on top of it. And so if you wanted the solutions to just work, it was easier to migrate your data from the old water wastewater model to the new LGIM, as we called it, because your solutions would just work, and it was easier to adopt the new data model versus customizing all of the solutions. Then in 2012, ArcGIS Online came about, and that drove a new web standard, and we started to decouple the LGIM, as we called it, into individual services because they were easier to deploy in a web environment. Then in 2018, we released a new technology for network management. This replaced our older geometric network technology for managing networks with a modern web services-based architecture for managing complex networks, which we call the utility network. So the utility network is really the new blueprint, the logical structure for how things connect and relate to each other, and the rules for those interactions. And so now our solutions are being built on top of that new framework, that new schema. So where that puts us today is the stormwater data management solution is built on top of that new data structure. So what does that mean? What is that solution? So the stormwater data management solution is a fairly basic, but it's extremely useful solution that provides capabilities to create, collect, maintain, and visualize stormwater data in a GIS. It currently does not include apps or capabilities to do things like conducting an inspection or tracing a network or doing any kind of repeatable analysis, but some of those capabilities will be out later this year and into next year. But our system is highly configurable, so partners and customers can take our technology and configure it for those workflows and then share that across the industry, which is commonly done today. So the value of that current solution is that it's built upon new technology that will likely serve as the best schema available for hopefully another decade. And the model is based on previous decades of user experience, resulting in a model that provides the most common features and attributes, not every feature and attribute, but the most common across the industry needed to manage stormwater assets. So the opportunity for the industry is to work with Esri and other vendors to incorporate additional capabilities based on the data requirements that you need to do your work every day. So as an example, if you need tools to collect data in the field on stormwater BMPs, tell us what those data requirements are, and we'll incorporate those into our solutions, or at least the most common ones, in the best way that we can. So where does that leave us, and where does the industry go from here? From the concept of data standards is that there's a lot of push-pull stakeholders that will contribute to how it plays out. You have vendors like Esri and Second Nature, who will provide more insight into the commercialization component of this topic here in a minute. You have regulatory agencies. You have associations like NMSA and others. And then most importantly, there are the stormwater utilities and the agencies that I believe are really at the helm in steering whatever kind of standardization best suits their need to get the work done. So what's Esri's role in this? Well, we will continue to collaborate with industry stakeholders. It's in our best interest to provide the best possible solutions that apply most widely across the industry. We'll continue to provide the common framework for GIS data, and we'll continue to deliver and extend our solutions for helping you to get your work done. So we'll provide the schema. Other stakeholders will provide the standards and the model, and then we'll incorporate that model on top of our schema into our solutions, again, in the best way that we can to meet the most common needs across the industry. And then there will be other organizations and partners that will build additional capabilities on top of that. So you have to tell us what those requirements are. And so I want to, at this point, thank you for letting me participate and letting Esri have a seat at the table. And Jason will continue this discussion a little bit further with a little bit more detail. And I failed to provide my email here on the screen, but if you want to get in contact with me about how to collaborate with Esri, my email is dwatchell@esri.com, and we'll try to make sure in a way to share that a little bit more effectively here throughout the webinar. So thank you.
Thanks, Dave. Jason, I'm going to make you the presenter. We got about 7-8 minutes left. So sorry, just wanted to give an FYI on that. You should let me know if you should be the presenter now. You should have that, Jason. Let me know if there's any challenges with that.
Should be working. How's that? Can you see it?
That looks good. That looks good. I will drop off.
Cool. Let's see if I can manage these two screens together. Hi, everyone. It's really nice to be here. Thank you, Seth. And thank you, Dave. That was a great, really, I think, detailed view into kind of how we see data standards and, in particular, kind of the cloud-based, GIS-based technologies really enabling municipal MS4 permit holders to build in the capability, the capacity to, among other things, satisfy the e-reporting rule. So my name is Jason Yoho. I'm the Chief Technology Officer at Second Nature, and I'm here to talk a little bit about the value of enterprise data standards. So I'm going to add the word enterprise to it as it relates to the MS4 compliance and reporting. I spent 15 years in Silicon Valley, most of my career helping industries understand how to adopt the cloud. So I would say that there's a digital transformation happening kind of at all scales of government right now. And what we are seeing is, the cloud adoption has really been accelerated, obviously, by the COVID tragedy, but it also represents a wonderful opportunity. The cloud does to put standards in place and adopt technological best practices as government goes through this transition. It reminds me a lot of the transition that the healthcare industry went through not that long ago. When we went to the doctor, we found the doctor had to kind of get our records, right? It was a fax, it was an email or something like that. Of course, today, that's no longer the case. You go to your doctor's office and they have easy access to your records online. A little bit about Second Nature to help you understand where we're coming from and how we are developing a perspective on the industry we build an open cloud platform. It's integrated with Esri's GIS technology, and it's for running stormwater programs and measuring program effectiveness and compliance reporting. Second Nature is an early stage technology company. We were founded in 2016. We're just over the hill from Silicon Valley in Santa Cruz, California. We now have customers in 12 states, so we're growing very rapidly. We have over 100,000 structural assets that are being managed for various stormwater programs within our system with a very high value of those assets. So we have a lot of data, a lot of information that really form the best practices that are shaping how we're thinking about data standards and how those enable e-reporting. Real quickly, I think the secret of our success is not just the cloud and GIS, but it's also that our methodologies and our models are based on science. Our founder and CEO, Nicole Beck, is a PhD in aquatic chemistry, and she really got her start working up in the Lake Tahoe Basin and the Keep Tahoe Blue project, trying to develop methods and models to understand water quality benefits for BMPs over time. We do hold ourselves to a very high standard from a science standpoint. We peer review and publish our science in scientific journals. In addition, of course, we believe in partnering. We know that it takes a lot of people to successfully run a program. Digital transformation, embracing cloud technologies is not about replacing people. It's not about replacing partners. In fact, it relies very heavily on partners. Data standards, of course, have many benefits, but at the core of the issue is the intent of the MS4 permit, which is to measure the effectiveness of the program at reducing pollution and runoff. To accomplish that, we need to be able to trust our data. We would say we need to have certainty in our data, and that certainty is based on methods that are statistically accurate and easily verifiable. Those are the foundation for trust. If we back up for a minute, and I'm going to try and go quickly here to meet Seth's deadline, if we unpack this need, it of course is driven by the regulation as represented in the permit, but what we've learned at Second Nature is that it's truly an enterprise requirement for data standards. So let's talk about that for a minute. And what is an enterprise data requirement? Well, the MS4 business need touches multiple types of systems: information systems, operational support systems, business support systems, and therefore relies on data and workflows across all of those. So it's a very comprehensive data requirement that is more than just data about specific BMPs or specific assets. From a compliance perspective, of course, that data needs to be easily reported and verified. From a business system, there's a requirement to measure, right? We can't improve what we cannot measure. From an operational perspective, we need to use that data to do our work. We need to manage our work. We have time frame requirements around things. And from an asset perspective, of course, it's about location, condition, and informing the other minimum control requirements of the permit. Stormwater programs, of course, have grown up over decades, relying on information systems and workflows, primarily from other municipal departments. It is difficult, it's expensive and inefficient to run a distributed program and distributed assets without a centralized system. And we all know, therefore, that there is a lot of complexity, there's a lot of cost, and frankly, sometimes there's just a lot of difficulty in being able to demonstrate effectiveness of programs. So we need to establish priorities, establish metrics to be able to do that. Data standards help break down those barriers and information silos. By moving to the cloud, starting in the bottom left-hand corner, we start to centralize programmatic and asset-related information in a way that's easily accessible. That enables us to start looking at workflows and work management, shifting over to the right a little bit, thinking about where are the opportunities to take out manual processes and automate and make things more scalable and easier to operate. Those things, of course, then present a foundation for really driving alignment for programs and ultimately plugging into other data systems at the state regulator level or even at the e-reporting level. So the picture is one of an enterprise vertical industry requirement: information, operations, business requirements with high stakes. There's regulatory compliance that's best serviced by aligning technology choices with a long-term architectural vision. By defining the requirement accurately and embracing best-in-class technology and standards, you start to enable your program to shift from a complex cost center relying on data services from other municipal departments to a digital service delivery model, one that allows you to communicate program effectiveness and to quickly and easily demonstrate and report compliance. The inverse of trust, of course, to a degree, is risk. We can see how data is generated using and used at each layer of your program systems. The nature of data, of course, is that it's not static. Therefore, there's inherent risk in doing nothing. As your program's generating more data, as you're using it to inform your program at every level, without a data standard, risk is actually growing, right? Data risk is either increasing or decreasing. And what we found is for many programs who haven't embraced the set of technology standards yet, that risk is increasing on a daily basis. And so if you get your data off the shelf, what you want to invest in is into producing the capability to transition from a static to a dynamic data environment. Of course, it's evolving. It's a target. It's not a final destination. I think Dave did a wonderful job describing how we all collaborate, how you all are a part of that collaboration. And as your business needs change, as your permit and your workflows evolve, the standard's going to evolve with it. The commercial pathway provides a scalable framework for iteration and ultimately really is the shortest path to high confidence in demonstrating your program effectiveness and being ready for the e-reporting rule. And then lastly, as we increase transparency and access to data and information, we really start enabling our industry to focus on the outcome, which is how our stormwater programs creating more cleaner and healthier communities.